Hello once again, AP Calculus students. Mr. Record here from Avon High School. We're going to take a quick look at some integrals of some very special trig functions. My period 4 class is on hand to take a look at this as well. I do apologize. We are working with the internal mic of the computer, so you might hear some of this obnoxious tapping. I'll try to keep that to a minimum, and then I'll do better and have my headset for my next video. So what we're going to be talking about here is, first of all, the integration of all of the trig expressions that you have been taught probably within the first maybe 3 days that you've been integrating. And of course, we've got our two very familiar friends, the integral of cosine, or the antiderivatives of cosine, and then the antiderivative here of sine. But then it's probably easy for you guys to question, well, what's up with the integral of tangent of x or the integral of secant of x? Don't they have answers? And they certainly do. But we could not learn those until you got deeper into your integrations with u substitutions and whatnot. Now, you did know these guys, right? The integral of cosecant squared, the integral of secant squared, as well as cosecant cotangent, and secant of x times tangent of x. They're basic integration forms. Now we're looking at some not quite as basic forms. So one way to do this is we could certainly just throw a bunch of formulas at you and say, hey, memorize it, right? What fun would that be? Or we could actually develop them and at least give you a means by which to find this integral of tangent of x. If you happen to see this on a test and you panicked because, oh, you forgot what the formula was, right? This is a great way to kind of fix that issue. Now, in order to take the antiderivative of tangent, though, you will have to do a little trigonometric identity work on it. You'll have to figure out what is another way to say tangent of x. Maybe the most common way to say tangent of x. And that would be sine of x over cosine of x. Hopefully, a lot of you were thinking that. And I know temporarily you might think, oh my gosh, we made this more difficult, right? We changed it from one trig word to two trig words. But it turns out that we've actually done ourselves a pretty big favor, because we can use u substitution, and given the fact that this whole lesson, the name of this lesson, basically, if you're watching outside of Avon, is how do you handle this? How do you integrate forms like that, 1 over u? And that pretty much dictates that our u would need to be the denominator, cosine. And I think you can probably start to see where this is headed, can't you? So the derivative of u is going to be negative sine of x, right? Swing over our dx like that. And we find out that, hey, this is all wonderful, this is all fine, because we have sine of x dx up here, and we have sine of x dx as part of our du, which is great, except for that negative out in front, but easy fix, right? We just simply float that negative, or offset with that negative, right? Don't really have to worry about reciprocating it, because a -1 upside down is still -1. Or actually, it's -1 upside down, 1 negative. Yeah, think about that. We're going to call it -1. So we'll integrate now 1 over u with respect to u, right? Which is the form that we wanted. Okay? At this point, we employ a formula that we've just learned. And if you're not real certain about what the antiderivative of a 1 over u form is, you might want to check out other videos on that particular topic. But we end up with the natural log of the absolute value of u plus c. And at this point, we could then just back substitute our original u in, which, if you recall, was this guy, right? Cosine of x. And that would be our final answer. Okay? And if I just push forward real quickly to the next slide before I come back and do the next example, we'll see that formula is right here in the second row in the first column. Right? Now, while we're here, if this is the first time that you're looking at this table, it's easy for you just to want to lose your lunch, isn't it? When you start looking at the secant integral. And if you look at the cosecant antiderivative. All right? But I'm going to show you how you can come and get the integration of secant by not having to memorize it here in just a moment. Before I do that, if you peek at the cotangent, it's probably likely that the approach to integrate this, the long method, would use a very similar approach that I did on tangent. The big difference is you guys would write cotangent as what? And you can tell me. Go ahead and shout it out to YouTube land. Cotangent, you would call that?
Cosine x over sine x.
You would put cosine on top over sine. And I think you were probably going to say 1 over tangent, which is right. It's not incorrect. But yeah, if you go cosine on top, sine on bottom, does it make sense that the sine is the u, and that's what we see in that particular expression? Does it also make sense that there is no negative out in front? Because the derivative of sine doesn't have a negative. All right? Now, I may have given you too much information. Maybe not so much my students, but I know maybe other students that could be watching this, because it's very likely that your textbook has an exercise where they ask you to prove what the integration of cotangent is. And I kind of basically explained the first few steps. But yeah, we've got to take a look at this guy. How in the earth are we going to integrate secant and get that terrible looking thing? Well, it starts off, as many little math proofs do, with a bit of a trick. And I'm going to take this secant of x, and just for the heck of it, just because I want to, just because I feel like it, I'm going to multiply it by the secant of x plus the tangent of x over the secant of x plus the tangent of x with respect to x. I mean, let's face it, isn't that like exactly what you thought to do anyway, right? Very straightforward. So I guess more than anything, I'm giving you an incentive to memorize the formula. Because if you don't memorize the formula, you're going to have to memorize this crazy step anyway. All right, now where does this take us, you might wonder? Well, let's go ahead and distribute this secant into that numerator. And we could get one single fraction out of the deal. Secant squared x plus secant x tangent x. And the denominator is going to stay as is. And then we start looking at this thing and like, yeah, boy, we made this easier, didn't we? We went from this step all the way to this step. But let's keep pushing. U is going to be what? Logically. Probably the bottom, right? Let's let U be the denominator. It's worked out so well so far, this particular section. So if we do that as our U, we'll take the derivative and see the derivative of secant is secant times tangent, is that right? And then add that to, and then what's the derivative of tangent? Secant squared, right? Swing our dx over. And what do you notice? Do you guys in my class here see it? All of this stuff is this numerator, isn't it? I mean, perfect. Offset with nothing. Don't even have a negative that you got to deal with. All right, so what does that in turn result in? I can use the right color. Well, you have a 1 over u integral, basically. You're replacing this with the u, and the stuff that I've highlighted in yellow is the du. And we know that the integration of 1 over u is natural log absolute value of u plus c. But what is the u once again? Yep, if we go back, I had it really at the top here. U is secant plus tangent, so I'll replace that u with secant plus tangent. It's very important when you memorize this that you know that there's a plus sign. All right? And the reason why I say that is it's very easy to get confused with this formula and mix it up with the derivative formula. Because if you recall, the derivative of secant, I want to say it has a secant and a tangent in its answer, does it not? But those two things are being multiplied, aren't they? Where in this integral formula, the relationship that joins the two trig words is a plus sign. So, all right, anyway, I hope this helps a little bit. Just make sure that you get your practice in, and these special new trig integrals shouldn't give you much trouble. All right, I'll see you next time.